So at the risk of overkill on these, the key is to remember when we have square units, the conversions are going to be altered or different from the linear or standard units. To get from millimeters squared to centimeters squared. On the chart, to go from millimeters to centimeters, we're moving how far? One to the left. So since it's squared, we have to move 2 to the left. So 2.7. Square yards into square inches. Now we went over this 2 days ago. We can do 8, hopefully I spell right. We can do 8 yards squared, and we can just convert it twice. We can convert it from yards squared to feet squared. 1 square yard is 9 square feet. And then convert it again from feet squared into inches squared. 1 square foot is 144 square inches. And of course, the yards cancel, the feet cancel. So you're just taking 8 times 9 times 144. But we could do this all in one step. We have 8 yards squared, put it over 1. We're getting rid of the yards squared and we're going to inches squared. 1 yard is how many inches? 36. So 1 yard squared would be how many inches squared? 36 by 36, or, oops. Try that again. 1296, yeah. For some reason my calculator wanted to fight me today. So times 8 makes 10,368. How many of you had that one?
You don't have to times by 8 squared.
Nope, because the square does not apply to the 8, it's the units. The only thing that the squared affects is that we have a different conversion factor. But yeah, this is not 8 squared yards, it's 8 yards squared. It's the yards that squared, not the 8. So 198 square feet into square rods. Now this one we have no choice but to come up with a conversion factor for. Square feet on bottom, square rods on top. Which one's the bigger unit, a rod or a foot? A rod. How many feet are in a rod? 16.5. So how many square feet are in a square rod? Well, 16.5 times 16.5, otherwise known as 272.25. So that means we do 198 divided by that. .7272. Otherwise known as 8/11ths, by the way. Yes, sir? There's one rod is 16.5 feet.
Yeah.
So, two square miles into acres. Well, 1 square mile. 1 mile is 5,280 feet. Now you might be saying, well, isn't that going the wrong direction? Isn't acres bigger than feet? Yeah, but we have a direct conversion from square feet into acres. So if we can do that, we can get it to square feet, we know how to get to acres. 1 mile is 5,280 square feet, which means 1 mile squared is how many square feet? A ton. 27,878,400 square feet. So that means 2 square miles. How would I find out how big 2 square miles is? times 2. So it's going to give me 55,000. Oops. $55,756,800 square feet. How do I convert that into acres? $43,560 square feet per acre. $1,280 acres in 2 square miles. 1 square mile, by the way, I can always remember how many acres are in a square mile. 1 square mile is equal to 640 acres. And the way I can remember that is, if you have a square mile, 1 mile by 1 mile. When you're buying large plots of land, how is it usually sold off? Not by a single acre, but usually it's sold off by, if you're going to buy a woods, you would buy a 40, right? 1 mile is cut into 4 sections. A 40 is a 1/4 mile by a 1/4 mile. This is a 40. 1/4 of a mile by 1. Pretend those are divided up equally. So that's a 40-acre parcel. So there's 4 by 4 or 16 40-acre parcels in a square mile. Now, normally what they do, land is sectioned off by square mile. In fact, in Barron County, they try to put a road every mile. So the roads are in square miles. But what they'll do is they'll do 40s. Usually along the north and south boundaries of the square mile. And then, since the ones inside there would be landlocked, they do 80s. Like that. But anyway, that's just how I always remember how many acres in a square mile. I know a 40 is a 1/4 mile by a 1/4 mile. Okay, so we left off yesterday. We were talking about areas. Doing some, not yesterday, 2 days ago. We talked about surface areas and finding the areas of a surface area of a cylinder. So I want you to try a problem here. I'll say more of a pipe, but a pipe, a machine tube, a barrel, whatever you want to. But whatever works for you. Okay. Let's say that this is 40 millimeters across, 60 millimeters long, and from here to here is 5 millimeters. I want to know the whole surface area, inside, out, and ends. If I needed to anodize this and coat it, how much surface would I have to cover to completely coat this part? All exposable surfaces. So I want you to take a second and think about it. I'm only going to give you a minute or two to lay out your plans. I won't give you time to start calculating, then I'll stop and we'll see if you're heading in the right direction. So if I'm looking at this, easiest way is probably to divide it up into surfaces. And the first surface I have to be able to find is this end over here. Well, this washer or ring or however you want to describe it. To find that area, think about it like this, as if I had a rectangle, let's say this is 12 inches by 20 inches, and I had another rectangle cut out of it that was, I don't know, we'll go 5 inches by 7 inches. How would I find the area here, all around it? I'd subtract. Yeah, I'd do 12 by 20, and then I'd do 5 by 7 and subtract, right? I'm going to do the exact same thing here. I'm trying to find the area of this ring. I'm going to find the area of the big circle. What's its radius? 20. This is 40 is the whole diameter, so that radius has to be 20. So that area is going to be pi times 20 squared. Now, if I use 3.14, I'm going to get 1,256 millimeters squared. Correct? We'll say yes. Now I need to subtract out that smaller circle. What's its radius? 15 millimeters. So that area is pi times 15 squared. Giving us 706.5 millimeters squared. And we're going to subtract 549.5 millimeters squared. Does that area make sense? So I'm going to make my list over here. I have 549.5 millimeters squared. Why am I writing it down twice? Yeah, we got this end, but there's this end over here as well. How did we technically accurate? I probably should have done that. So now I have two more surfaces to go. I've got this surface here that wraps around the whole outside, right? That's actually, if I cut that and I open it up, it becomes a rectangle. The length of that rectangle is still 60 millimeters, isn't it? Because if I look at it like this, here's my cylinder. There's my circle. I slice it down the side and I open it up, and that outside surface is a rectangle. This height here is still the height of the cylinder, or length of the cylinder, however it's sitting. What is this distance across here? Well, that is just the circumference of that circle. So we have 40 millimeter diameter times pi. We're going to give us that circumference, which is 125.6 millimeters. Does that look right? So that's going to give us, what, 7,233.6 if I multiply those out. Multiply those out. What do I get? 125.6 times 60. 7536. Ooh, I missed that. Decimal point out. 7,536 millimeters squared. So that goes on my list. What surface have I still not found? Yeah, this inside piece. Well, that's going to be the same way. I'm going to open it up. It's going to make a rectangle. What's the length of the rectangle going to be here? Still 60 millimeters, right? It still goes end to end. Now this piece here is going to be around this circle, right? That's got a diameter of 30. So it'll be the circumference of a circle that's 30 millimeter diameter times pi, which is going to give us that 994.2, I believe, millimeters. So 94 point, what's that? 94.2. So 94.2 times 60. 5652 is that area. So we got to add that over here. Now to get our total area, we got to add that all up. $14,287 millimeters squared. What do you think? Yes. Okay. So enough review. Is there a question? Yep, the 60 is this distance. The 125 is this distance. So multiply those two to get to 7536. Yeah. Okay, so enough review. We were taught, one of the things we talked about is triangles. So we're going to focus on triangles today. And we've looked at several different levels of difficulty. The simplest one we looked at was like this. A right triangle, where let's say this might be 14 inches and 6 inches. How did we find its area? Yeah, 14 inches times 6 inches times 1/2 or divided by 2, however you want to think about it, comes 42 inches squared. And the reason we did it that way is that 14 and 6 are the length and width of a rectangle that would contain that triangle, and that triangle is just half of that rectangle. If it's a right triangle, it's very simple. We did run into triangles like this, where it's not a right triangle. Let's say this is 16 inches here. What we need to know, we still need to know the dimensions of the rectangle that contain that triangle. Now the length of that rectangle is 16 inches. We need to know the width of that rectangle. On the triangle, the dimension that would give us that width would be, we've got the side of 16, we go to the opposite corner, it's called the vertex, the opposite vertex of the triangle, and we measure the distance back to that side that we have the length of, the 16-inch side. Distance is always measured at a perpendicular, at a right angle. So if we know that distance, that would be called the height of the triangle. And let's say that for this triangle, that's 5 inches. Another technical term for that is an altitude. It's an altitude on this base from the opposite vertex. But now we know our area, that rectangle would be 16 inches by 5 inches. And so the triangle is divided by 2 because it's still half of that rectangle, so 40 square inches. If you look at it, if I look at this side, the triangle takes up half of that part of the rectangle. Look at this side, the triangle takes up half of that part of the rectangle. So it is still half of the whole rectangle. Well, it's a little trickier to comprehend. What if our triangle is like this? Let's say that this across here, we'll go back to being 12 inches again. To measure this opposite vertex here down to this side, it doesn't actually come at a right angle. So we have to extend the side out to measure down to it at a right angle. Let's say we measure that and it's 7 inches. Can I do 7 times 12 divided by 2? Yeah, that will work. It'll give us the area. But how does that come back to be our triangle or our rectangle? Well, I'm going to do this. I'm going to tell you that this length is 5 inches. So if I tell you that that length is 5 inches, we now have 2 triangles. We have this one here, a big triangle. Pull that off to the side. This here is a right angle. This is still 7 inches. What's the length across the bottom here? 17 inches. The area of this triangle would be 7 times 17 divided by 2. Otherwise known as, what, 59.5, I believe? Inches squared, is that correct? Okay. We also have this little triangle here that would be subtracted out, right? How big's that? Yeah, it's 7 here and 5 down here. You had the right idea. Its area, yeah, 7 inches times 5 inches divided by 2 makes it 17.5 square inches. And it's easy to see that each of those is half of a related rectangle, right? Because they're right triangles. Well, if I subtract those numbers, what's left for this triangle? Well, it'll be 42. 59.5 minus 17.5 is 42.0, or just 42 inches squared. What would I get here if I just took 12 inches times 7 inches and divided by 2? I would get 42 inches squared. So it still works out. It is still half of that related rectangle. So my related rectangle here is just this one. Even though it doesn't look like it, it is, that triangle is half of that rectangle. Any questions? Yeah, you could do 12 times 7 divided by 2 and you'll get the same result. That's all that is. I was just showing you that because a lot of people get confused of, well, this is out here and this doesn't fit inside the rectangle. It does. You're fitting inside pieces of rectangles and putting it together. So anyway, if we have a right angle, it's easy to find the area of a triangle. But what if I give you a triangle like this? And I don't indicate that it's a right angle. And while that doesn't look totally, I mean, it looks like it's close to a square corner, but it doesn't look perfect. So we really can't assume that that's a right angle. I cannot assume that this is a right triangle. Is there a way I can tell? Well, if I have a right triangle, so I'm going to tell you that this is a right triangle. There are 3 sides, of course, to any triangle. In a right triangle, 2 of the sides make the right angle? The two sides that make the right angle are called legs. I remember that because they make an L. A right angle looks like an L, so those are the legs. The third side does not touch the right angle. That is called the hypotenuse. Which of those three sides is longer? The hypotenuse is always the longest side. So over here, if this were a right triangle, which side would have to be the hypotenuse? 17, the longest side. So if this is a right triangle, the 8 and the 15 must be legs. Now we don't know their legs yet because we haven't checked. But back over to here, if I call the legs, we usually label the sides of a triangle with small letters. So if I call the legs sides A and B and the hypotenuse side C, there's a relationship called the Pythagorean rule, Pythagorean theorem, however you want to put it, that says the length of side A squared plus the length of side B squared equals the length of side C squared. So over here, if I want to test to see if this is a right triangle, I can use that relationship. Doesn't matter which one I make A or B. Doesn't matter which one's A and which one's B, but there are two of them that have to be A and B, which would be the 8 and the 15. So I can make the 8 either A or B, and then 15 has to be the other one. 17 must be side C, because it's the longer side. So I'm going to put it over here. 8 squared plus 15 squared. Notice I'm not putting in an equal sign here. I'm just leaving it blank there. I'm not putting in an equal sign yet because I don't know if they're equal. 8 squared is 64. 15 squared is 225. If I add those, I get 289. 17 squared is 289. Those are equal, which tells me that this is a right triangle. So if this is a right triangle, where's my right angle have to be? Between A and B, between the 8 and the 15 millimeter sides. The two shorter sides must be the legs. They must form the right angle. So now to find its area, which two sides do I use? The legs, A and B. So 8 millimeters times 15 millimeters divided by 2, which gives me 60 millimeters squared, square millimeters. What do you think?
So what happens if it's not right angle?
We're getting there. In your notes, tell me if that is a right triangle. Is it a right triangle?
Yeah.
Yes. Where would the right angle have to be? Yeah. Between the two shorter sides, 40 and 9. And if I set it up, I'll make it A, B, and C. Obviously, 41 has to be C. A and B can be whichever ones of the other two we want. I go to do this. 9 squared is 81. 40 squared is 1600. And that adds up to be 1681. 41 squared is 1681. So this is a right triangle, which means the area is found by doing what? The two legs, 40 times 9 divided by 2, or 180 millimeters squared. Yeah, we'll go down a little. So now in this triangle, is it a right triangle? No, it's not. The 7 and the 11 would be the shorter sides. 12 is the longer side. So if this is a right triangle, that would be the hypotenuse. 7 squared is 49. 11 squared is 121. That adds up to be 170. 12 squared is 144. This is not a right triangle. How can we find its area? Well, if I knew an altitude or a height from one of the sides to the opposite corner, whether it's that one or even this one or whatever one I know, I could find the area. But I don't know that, and I'm not going to give it to you. So to do a problem like this, a Greek mathematician named Heron created something called Heron's formula, or sometimes called Hero's formula. And what Heron developed, he said, if you find the perimeter of a triangle, from here on out, just abbreviated with a P. What's the perimeter of this triangle? 7 inches plus 11 inches plus 12 inches, which adds up to 30 inches, right? Heron then defined something called the semi-perimeter. Here on out, to be abbreviated with just an S. The semi-perimeter is just the perimeter divided by 2. So for this triangle, 30 inches divided by 2 is 15 inches. So then Heron discovered that if you knew the semi-perimeter and if you knew each of the sides of the triangle, now I'm just going to label them from smallest to largest, A, B, and C. You don't have to label them in any special order. Any side could be A, B, and C, but I'm just used to having the two smaller sides be A and B from right triangles anyway. So I'm going to label them. It's just easy if I label smallest to largest. He said the area of that triangle is equal to the square root of the length of the semi-perimeter times that semi-perimeter minus the length of side A times that semi-perimeter minus the length of side B times, you probably see it coming, the semi-perimeter minus the length of side C. So the area here is going to be our semi-perimeter of 15 times 15 minus side A is 7 times 15 minus side B is 11 times 15 minus side C is 12. So this is 15 times 15 minus 7 is 8 times 15 minus 11 is 4 times 15 minus 12 is 3. $15 times 8 times 4 times 3 is 840. No, it's not. I lied. 1,440. Look better? Yeah? All right. So let me square root that. 37.95. 37.95. Now those sides were in inches, so this area is in inches squared. I'm going to pause there for effect. Give you guys a second to catch up, catch your breath. See what I did there for all those? Let's do one more example together. Then we're going to have you try one all on your own. So let's see, this one is 10 inches, 15 inches, and 16 inches. Tell me where to start. Okay, we can see if it's the right triangle. It's not.
It's not.
Yeah. 10 squared is 100, 15 squared is 225, that's 325, 16 squared is 256. Find the perimeter, very good. I'm going to leave off the inches just for time. 10 plus 15 plus 16 is 41. Divide by 2 to get the semi-perimeter. So 20.5. And then? Okay, so ABC. So 20.5 minus 10, okay. 20.5 minus 15. 20.5 minus 60. Good. So, this is the square root of 20.5 times 10.5 times 5.5 times 4.5. Now, I'm just going to punch this in my calculator all in one thing. Second square root, 20.5 times 10.5 times 5.5 times 4.5. Gives me 72.99. Inches squared. What do you think? Not bad? Better than a sharp stick in the eye? Thanks. That's right, I keep forgetting about that. Well, you know what? There might be a reason why you're required to have some sort of eye protection when you're riding a motorcycle. I mean, they don't. You're not.
It'd be over for you if you're on a motorcycle.
Yeah. Oh yeah. You got hit in the eye with a bug, you'd be screwed at 70 miles an hour. In your notes, find me the area of that triangle. Okay, so perimeter gives us what? 48. Semi-perimeter. (48) divided by 2 is 24. So for our area, I'm just going to go ABC. Square root of 24. 24 minus 12. 24 minus 17. 24 minus 19. So 24 times 12 times 7 times 5. Gives us 100.40 inches squared. What do you think? We could do worse, right? Okay, well, I'm going to end this recording here. I'm going to hand out homework. I'm going to be giving you a packet. In this packet, it's going to be page 144. Through 147. There's going to be problems inside a gray box. Those will be your homework problems.